People are asking the question, why should I buy a 406 megahertz PLB as opposed to carrying my cell phone, a satellite phone? Will my GPS work? Or even these new satellite messaging devices. What's the difference? We get that question frequently. The problem is that all of these devices are really designed and intended for some other use. A PLB is a device of last resort that was designed, the entire system was designed and conceived by the search and rescue community around the world to be a dedicated device of last resort that will work when all other means of self-rescue have been exhausted. Let's talk about what happens when you push that button. The first thing that happens is we turn on the GPS receiver inside the beacon and we began acquiring GPS data from the GPS satellite system, which is a separate system. Those GPS coordinates, when available, are incorporated into the signal, and that 406 megahertz signal goes blasting at 5 watts through tree canopies, meteorological activity, whatever, into outer space to 2 different satellite constellations. The first of those 2 search and rescue satellite systems is called the LEOSAR, or the Low Earth Orbit Search and Rescue Satellite System. Every point on Earth, on average, is covered or viewed by these satellites roughly every 90 minutes. And they can locate the 406 megahertz beacon using a phenomenon known as Doppler shift. A lot of people think of this as a form of triangulation, and it is in a way. But using the Doppler shift phenomena, they inherently locate the beacon based upon its signal. Now, remember, the signal also can carry your GPS data. So now we have your position through Doppler shift as well as through GPS-derived coordinates. The second constellation in the system is called the GEOSAR, Geosynchronous Search and Rescue Satellite System. And these satellites set at 22,000 miles altitude. Their orbit of the Earth is once every 24 hours, so their view of Earth is continuous or synchronous. It doesn't change. Any 406 beacon activated within their field of view, which is huge, is heard by those satellites in a near instantaneous fashion. They don't have the ability, like the LEOSAR does, to locate you using Doppler shift or any other technique, but if you have incorporated GPS data into your transmission, then the GEOSAR knows who you are, where you are by virtue of your GPS data. At this point, both the GEOSAR and the LEOSAR rebroadcasts that alert message to LUTs, or local user terminals. The local user terminal forwards the alert message along with the position data to the appropriate MCC, or Mission Control Center. The MCCs are the link in the chain where your registration information resides. Each of these beacons has a unique serial number, and that serial number is matched to your personal file. That information is added to the alert message and it is forwarded on to the Rescue Coordination Center. When the RCC receives the alert message from the MCC, it then knows where you are, who you are, and that you're in trouble. It has all of the information. And the RCC coordinates with the local rescue agency and instructs them to begin the process of putting together a rescue party. At the same time, they actually begin calling the contact information that's provided in your registration form. And as soon as the rescue agency can organize the rest of the details of the rescue party, they hit the ground running. And they use the 121.5 megahertz homing signal in the beacon to actually come to your location. So in every one of these beacons, there is a built-in multiple levels of redundancy to ensure that they work when you need them most.